Hi there, my name's Dave. Usually I make video games, I guess I make YouTube videos now. Let's play with Pico-8. We're at pico-8-edu.com. Start it up. Alright, I'm going to show you a little math thing. Don't be scared. We're looking at this circle. And we're looking specifically at these two functions, cosine of x and sine of x. Now you might remember this from like trigonometry class, geometry class, something. I never understood in school what these were good for. It's like triangles, who cares? In video games, I use it all the time. It's so useful. So I just wanna, it's a little hard to explain. I'm gonna write some code. Hopefully it'll make sense. Okay, we got our three functions. Write them before I do if you can. Function init, function update. We'll just do regular update today. We don't need this to be blazingly fast. And draw. Okay. Now I want to set up something here. Stick with me. We're going to define a radius. R is going to be 56. We want the center of the screen. I don't want to have to type like 64 all over, and I want to be able to change it if I want. Here's a cool trick. You can define two variables at once or more with a comma. So you can be like gx comma gy equals, and then two values, 64 comma 64. And you can do this with like a bunch, and the like kind of cool superpower of this is like you could define multiple locals at once. It can start to get kind of hard to read, so I don't use it that often, but like when something is logically grouped together, like I want this gx and gy together, I think it's nice. Okay. And then I want a tick that's going to start at 0. So this is like the tick of a clock, okay? Hang with me here. Every update, we are going to do tick plus equals 0.01. All right? So every frame, our ticking clock is going to just, not even one, just 1/100th. All right. Now, clear our screen. We're going to draw a grid of sorts. We're basically going to try and draw this circle with the axes here, the x and y. So we will do circ gx gy for our grid center, r for the radius, and just keep the color 1. Hey, and we have a circle on the screen. Great. Okay. Now we need like lines going through it. So we'll do line. Line takes like a coordinate, x0, y0, and then like a second coordinate to draw 2, and then a color. So we're going to do the center of our grid, and then we're going to do, or I'm sorry, we don't want to do the center of the grid, because let me show you. If we do that, gx plus r, and keep the gy the same, give it that color 1, it'll draw from the center out, and we want to draw it from one side to the other. So we want to do, we're doing the x-axis here, minus r. All right, so that'll split it in half. And then we basically want to do the same thing. We want to do gy, gx, actually, no. We want to do gx, gy minus r, and then keep that x the same and change the y. All right. So we've got like kind of our crosshair. That's just to sort of be a reference for us. Now we're going to do some calculations. Going to make two locals. just for our convenience in this little experiment. This is going to be cosine of our tick. Let's just keep it at that. All right. We're not doing anything with those yet. So let's draw some lines. We're going to do line GX, GY, so start from that center point. GX plus our cosine local. Keep it locked to that Y, and we're going to make the color 3. Now look at that. It's just kind of wiggling. What is it doing? Well, let's amplify it. So we'll go to our calculations and we'll do times r radius. And let's see what that does. Okay, now we can see it. We've kind of turned up the volume on this. What we've got here is a kind of sine wave. You may have seen this if you've like worked in audio or something. It's kind of movement like a snake. All right, and this is really useful. Like, let me put in a second line. We can do GX, GY, and then we'll keep the GX and we'll do GY minus our S value. We'll make that color 11. Okay. So yeah, you can sort of see if you've got like an enemy that's like a bat or something and you needed to sort of move up and down, the sine wave is really helpful for that. Now we've got cosine on the X there, and we've got sine on the Y. And they're both kind of doing this wave. What's the deal with that? Why is this useful? But they're not the same, right? They're two different functions. They're taking in the same tick value. We're multiplying it by the same R, but they're like offset from each other. What good is that? Let me show you. All right, circ GX plus C GY minus S. Give that a radius of 4, color of 7. So if we just do GX and GY, right, it's just drawing at the middle. But if we add our cosine value here, and we to the X, and from the Y we subtract the sine, so it's going to sort of line up with these lines. What's it going to do? It's going to trace the outside of that circle. So the sine and cosine functions are fantastic for essentially taking an angle and translating them into X and Y coordinates. It's great for circular movement. It's great for like aiming. If you have a turret or just a character who can aim, it's great for if you have like a vehicle and it has a direction and you want to translate that to an X and Y velocity. Super useful. Use it all the time. Now, what is this tick value that we're passing into the cosine and sine functions? Let's draw some text to the screen. We can use the print function and just print tick. I'm also going to print the floor of C. Now, floor is a new function for us. It's sort of like rounding, but it always rounds down. And like this number is going to be, it's just going to like flicker a lot if we don't round it. So this is just to sort of clean it up. All right, so this is our cosine and sine values. We're just going to print these to the screen. Okay, take a look at these numbers up at the top. Now you'll notice every time our circle passes around to where it started on the right side, our tick goes up to a new whole number. 7. 8. Right? And every time it's at like the half value, the 0.5, it's on the left. The reason is, usually with these cosine and sine functions in a lot of programming languages, you use something called radians, which is a number I don't think anybody but mathematicians like really. That's not true. People are going to be like, Dave, you don't understand radians? Yeah, goof. People are going to judge me for not understanding radians. It's just a weird number. It's like based off of pi. It's just, it seems so abstract and like arbitrary. They've never been useful to me. And so usually you think about a circle in degrees, like 0 to 360. And then in a lot of engines, you then convert that to radians because nobody really likes working with radians. In Pico-8, they use something called turns, which I think makes really intuitive sense. And it's just how many times, how much of a turn around a circle are you doing? Is it a quarter turn, a half turn, 3/4 turn, or somewhere in between that? A full turn goes back to 0. So it's a value between 0 and 1. And then it like loops around when you go over that. So what can we do with this? We could rename this to angle, get rid of this, and then we could do if button left angle, let's just, I don't even know which way to go. We got to do plus equals something, 0.01. If button right angle minus equals 0.01. All right, I got that reversed. We'll do minus equals here, plus equals here. Change this to angle. I can control this. And I can even do angle percent equals 1. That should work. Yeah. So we're using our modulo, that percent, to keep it sort of locked between 0 and 1 and loop it around. So when it hits 1, it goes back to 0. When it goes into the negative, it counts down from 1. And we can really visualize here that like 0.5 is to the left, right? And as I bring it around, 0.75 up at the top, 0.25 at the bottom. Pretty cool. So I've made like a turret here. What if we play with this? We'll make our radius 32. No, We'll make our radius 8. We will, let's do a speed 0.1. Speed this up. Too fast. 0.05. Alright, that's kind of neat. Now what if button up, then, here, we'll move this. Move this down here. Gx plus equals cosine of angle gy plus equals, let's do minus equals sine of angle. Oh. So yeah, now we've got like tank controls. Let's make this guy bigger. You can really see. Those little lines we drew is the result of our trigonometry, of our sine and cosine, and they correspond to the x and y that we are adding to our tank's coordinates to move it in that direction. Let's do bullets equals, make a table for our bullets. Make a new tab here. We're making some messy code. I'm just showing you stuff. We're kind of doing jazz right now. We'll do bullet add xy dx dy for the direction of the x and the direction of the y. We gotta declare this a function. Okay. Add this to our bullets table. We're going to make a new table. X equals x, y equals y, dx equals dx, dy equals dy, life equals 30. Okay. Function bullet update end. For b in all bullets, do b.x plus equals b.dx, b.y plus equals b.dy, b.life minus equals 1 if b.life is less than or equal to 0, then delete from bullets B. Function bullet draw for B in all bullets, do circ fill b.x, b.y. We'll just give them a radius of like 2 and a color of 8. All right, and then we have to add this to our draw. What did we call it? Bullet draw. Update bullets. Bullet update. And if we do if button X, then split add. You know what? Let's just do it from the center. And then the direction will be cosine angle. Format this a little nicer. Cosine angle, negative sine angle. Let's see what that does. Interesting. Oh, I want to do if button P, so that it only shoots one bullet. Although, that's kind of cool. How do we speed this up? Well, we can just multiply this value by, I don't know, 5. Make it arbitrary. You know what? Let's be precise about this. Let's do split speed equals 5. We'll shorten it to B speed. Pico-8 style. And then just right here when we create it, we'll do dx times B speed. Ah, kind of cool. We can move around. We can shoot. And if we wanted, we could just change this to button P. So that was kind of a lot of code. Kind of a mess. Not necessarily how you'd want to structure a game. But hopefully you're starting to see, outside of math class, how cosine and sine are super useful in making games. And I want you to go play with it, make some sine waves, animate some things in a circle, experiment with what happens if you don't do negative sine, what happens if you put different numbers into the sine and cosine. Really try and get an intuitive understanding of how to use these numbers to make cool stuff. Thanks for joining me. I hope you had fun. I guess we're making videos now. If there's anything you want to hear me explain better or at all, drop a comment, give me feedback, let me know how I'm doing. I will catch you in the next one.